Yeah, so I'm Dave. I am CTO and a co-founder at a company called VisiBuild. This has absolutely nothing to do with what I work. I have no idea what I'm talking about. This is mainly just for fun. I had this idea at one point when a talk was talking late last year, and I was like, what would be interesting but like equally unknowable to talk about? And I was like, oh, it's good. I'll just talk about making a malicious Ruby gem. I feel like there's a lot of weird stuff out there with like tech security, and like I'm sure Anton can probably talk to this more than I can, but it's really interesting to me to understand what people are doing and how people are getting potentially exploited. So yeah, like I said, not a security expert, just having fun. You can find me on weird socials and stuff like that. Otherwise, you can talk to me. I'm a real person. I'm here. But yeah, let's kick off. Oh, before we do that, please don't actually just take this and do it. Like, this is supposed to be like a scammy little like scary tactical thing. It's not supposed to be like a handbook on what to do for your first ever Ruby gem publication. There's that. Yeah, let's begin. So before we dive too deep into it, I guess want to clarify what I mean by malicious and the differentiation between vulnerable and malicious. So a vulnerable thing is something that has a potentially exploitable nature versus something that's malicious, which is attempting to exploit something which is potentially vulnerable. So I've got a little visual diagram to help with this. Here's Kevin. He's in his vulnerable home, but he leaves his front door open all the time. He's not happy about it at all. He's very, very angry. It took me about 6 minutes to put that together. I'm very proud of myself. And by comparison, here's Kevin in his high security prison that no one can get into, except there's one thing we all know about Kevin. He really loves big wooden horses. So he's like letting this big wooden horse that is totally not malicious at all into his prison and hoping for the best. But the reality is that it's going to really ruin his day. So maybe just stay off the wooden horses a little bit. Yeah, so I mean, at the end of the day, like, things are out there that are malicious. So it's important to kind of recognize that and think about how they might exploit you. So that's kind of what I'm going to be talking about today. By show of hands, who thinks they're potentially exploitable or at risk of being exploited by their supply chain or package supply chain? And what I mean by that is like the things that run in your code, but like in production. Okay, so about 30-40% of people. All right. For the rest of you, I'm going to encourage you to put your hands up at some point tonight. So we will get there. But I guess the question is like we all run code in other people's code in our environments. If you publish that code, what would your number be? Like, you would all have a price, right? How much would someone have to come to offer you to put a backdoor in your code or to exploit some other person's code base through you, right? Like, everyone is exploitable in some way, shape, or form. And the good people that make open source software are typically less exploitable than others, I'd hope, or there's enough review around this stuff that it doesn't actually get out, but everyone's going to have a price. And so, yeah, maybe think about that before you start contributing to some of this stuff. If I keep looking down at my phone, that's because I have no idea what I'm talking about and I've written a couple of notes. Cool. So who's heard of these gems before, by show of hands? Okay, some people. So Datadog is like a reporting tool. Airbreak's like an error reporting tool as well. Active Tools is just like another active supporting gem. Who's heard about these gems? So which one is the right one? Who wants to take a stab at that first row? Datadog _CLI or Datadog -CLI? The left one. The left one, Datadog _CLI? Well, you're wrong. Unfortunately, you've just opened yourself up to an exploitation. What about the next one? Are we sticking with the underscores? Are we going hyphens now? Who wants to take a stab? What? None. Oh, actually, one of these is right. It's hyphen this time. Or it's actually hyphen last time, hyphen this time. And for the last one, hyphen again? Underscore. It is underscore. Yes. So, but like the thing is, like, this is a type of exploitation that can be done. It's commonly called typo squatting, where you sit on a package name that's very, very, very similar to an actual package, And you can like basically just require that underlying actual package in your package, require it, and it can pretend to be its actual package. But on top of that, because you now have a container to run your own code in, like you're probably doing something malicious. And these were actually 3 gems that came from a much larger set of about 700 gems, and that accrued up about 95,000 downloads about 3 years ago. So this is like a real thing that happens, and it's like possible to kind of get exploited by this. Maybe you type in the wrong thing, do it by hand. Maybe someone gets great SEO on their own hacker website that forces you to copy their thing. Maybe you just don't even think about it. You know, you just enter both or just whatever comes first to mind. But it's really, really, really easy to kind of to get stuck in this. And like, there's other ways of doing it too. Like maybe it's a typo with like you switch A and D or A and T or something, and you just quickly type in it and it's in your gem file, everything's included, everything works fine because that underlying package is still there, but you don't, like you introduce this vulnerability within your system and then you commit it, everyone else in your team gets it, maybe it makes it way out to production, suddenly you're in a little bit more of a painful situation. So I just want to dive into these particular gems and in fact, this whole set of 700, just to show you what it actually did. It's like a little bit interesting, a little bit tricky. But all these 700 acted the same way. I'm assuming this guy had a small script that like tried to publish a whole bunch of different gems with the same kind of wrapper on it. So what this wrapper did was, if you didn't know this, when you install a gem, you have the potential to run a makefile, which is responsible for executing a compiler to compile a native extension alongside your gem. That's typically used for speed ups and small native APIs you may want to compile into C. And basically all it is a way for you to run your own code. And it's good because it improves everyone's performance in Ruby. But this makefile, what it did was it just copied a random PNG file in the gem repo into a file and just renamed it as .exe. Turns out they'd included a Ruby bit of code that they'd compiled over to an executable and then renamed the extension, and then this makefile copied it back. But when this makefile executed as exe, it didn't actually do anything directly. What it instead did was make a new Visual Basic script that copies over into a C directory, and this only affected Windows people, but it copied over to a Visual Basic directory, and every time you rebooted, this thing would restart as a service. You know, it doesn't sound so bad, it just runs in the background. What is it potentially doing? If you're into crypto, bad news, what it's going to do is every time you copy something that looks like a Bitcoin address, it's going to replace your clipboard with the hacker's Bitcoin address. So anytime you want to send your friend 20 bucks in Bitcoin, whoopsie, you just send it to the hacker. I'm not sure if anyone did any research into how much money this guy actually funneled into his account, but it would be pretty interesting to look into that and actually see what went on there. So it's a pretty convoluted example of like an attack that was made. And typically a lot of these repositories and package repositories protect against stuff like this. So they use Levenstein distance. I don't know if I'm pronouncing that right, but basically it's the distance between 2 words. So, and the way it's measured is how many characters you have to change in one word to reach the other word. And if things are close and that other package is highly used or widely available, then chances are you get blocked or flagged in some way. And I think that's how they actually found these ones, but I'm not too sure. So that's a pretty convoluted and complicated example. Let's build a little bit of a simpler one and start from there. So who's actually built and published a gem before? Help people? Yeah. Who hasn't but knows how it's done? Cool. All right. We won't go too much into publishing gems, but like, don't worry. I am like not at all a prolific gem distributor. I think I've got maybe like a very like I used to publish some gems from my work and they would use my gems. So publish dev tools and random stuff, but yeah, 17. It's not a very big number. Don't worry about it. We're all kind of in the same boat here, and trying to all figure out what's going on. So to sort of paint the picture of the landscape we're going to be playing in today. Also, again, please never attempt to do this. God above, I will come to your house and cut off your arm so you can't code ever again. This is for just like a little bit of playground and a little bit of a scare tactic. So here are the players, right? We have a Rails repo, which I have called Ministry of Magic. We have a gem called Grindelwald, which if you've been watching the most recent Harry Potter films, he's a bad dude, right? Don't let him in your house. And we have this little thing, a malicious meter. So this is going to sit on the side of our slides and show us, I guess, how naughty we're being. So to give you an idea, let's just jump into the repo. So here's the Ministry of Magic repo. It's pretty basic. It's got a couple of models in it: school, user, wizard, and we can start it up. Here it is. We can log in. So let me zoom in a little bit. He's got a very secure password. It's password. Don't tell anyone. It's a secret. But then we have this very basic CRUD looking web app, right? It's got schools. It's got wizards. So we can make a new wizard. Kevin, congratulations. You got admitted. But not into Hogwarts, into my school of magic. Perfect. There you are. So we can do whatever we want in this little app. It's not very complicated. It's just for demonstration purposes. We also have our gem. So this is our gem over here. It's just a little like Ruby create gem situation. It's got some code in here. At the moment, these are all kind of empty, and we'll populate these as we go. So let's begin. Let's start with something a little bit like nasty, but not too nasty. So one thing I really hate in my day-to-day life, oh my God, this image is going to take about 1 million years to load, it seems like. It's a very little part. Just hold on. By the way, I got ChatGPT to help me out in the image department. No, not ChatGPT, DALL-E. I asked it to illustrate flaky tests. This is what it came up with. So if you don't like the illustrations, don't blame me, blame the computer overlords. But I hate flaky tests. If I see a flaky test, I'm screaming at my computer. At the moment, we have this weird flaky test that I haven't been able to fix yet, but it only happens if you run our test suite from 1 a.m. to 3 a.m. So all these automated bots that are contributing stuff to pull requests are now suddenly breaking, and everything else is working fine. So it's very annoying. But anyway, I hate flaky tests. I'm sure everyone does too. It kind of ruins your day. So let's make your test flaky by including our gem. So let's start here with a bit of a flaky test situation. We've called this test disruptor, and all it's really going to do behind the scenes is jump on top of the existing testing framework. So in Ruby, there's a concept of monkey patching. If you haven't heard of it, by the time you like get into Ruby a bit more, you'll probably be very sick of hearing about it or like very against it. But it's this idea of in Ruby, you can actually just reopen classes and define whatever you want on top of them, override things, do whatever you want, and have a lot of fun at the expense of whoever's running your code. For example, you can redefine what plus does. Instead of adding 2 numbers, it's actually going to minus them. You're like, oh, okay, cool, great. I can't wait for that. So we're going to do something a little bit similar. We're going to try to, instead of when you assert something, instead of being true all the time, it's going to be true most of the time. So this is how we're going to do it. So we're going to make a module. We're going to call it assertion extension. And this is the thing we're going to like insert over the top of our stuff. We're going to make an assert method, and this is going to override the default assert method, which typically comes with a test, which is either true or false, and a message, which has a default nil. And we're going to call super, which is going to call the default assert method under the hood. And what we're going to do here, instead of calling test, which is what super would do, like providing that in that argument, we're going to do something a little bit sneakier. We're going to call, basically, if you're running CI and ran less than 0.3, so 30% of the time, it'll take this branch, which is going to fail. And then the other percent of the time, or if you run it locally, it's just going to pass a long test. So if you're in CI 30% of the time, good luck. Hold on, everybody. This is going to be rough. And everything else is all good. And to be able to actually do the monkey patch itself, we're going to have a small method here called inject. And that's going to do a couple of things. It's just going to check if the mini test to capital T or lowercase t? Lowercase t. Mini test assertions is defined. It's also going to return if we've already done this before. And then it's just going to prepend our code. And if you don't really know what this line does, don't worry too much. All basically we're doing is we're inserting our code to run instead of the actual code. And then we're able to call super, which will call the actual code behind the scenes. So we're just injecting ourselves into the process a little bit. We also have this other little file called a rail tie. If you're not sure what this is, again, I know I'm covering a lot of weird things. Don't worry too much. This will just run whenever our Rails server starts. And all this is going to do is inject our stuff. So we go test disruptor, inject, and we also have this YAML file that I've made just to help us turn things on and off. So at the moment, test disruptor is off, we can turn it on. And so this rail tie will only run this method if this test disruptor flag is true, which now it is. So we have everything we need. We've got a rail tie that will require our code. Our code will run, which will inject our own different code on top of it. And we can go from there. So if we go back to our Ministry of Magic, we can open a new terminal, run our test just to confirm it's all working. It runs, great. Cool, it runs all good locally. Let's try NCI. It ran, good. It ran, oh, no, it failed. Still failing? It's still failing. I probably put something buggy in there. Oh no, it's still failing. Oh, it ran again. It ran successfully. Congratulations, you got it. You got through. So you're just rerunning your tests every single time and hoping for the best. That's like one way we can be a little bit nasty, but ultimately it's not going to ruin everyone's day. You could reduce that amount and just hope no one notices the fact that you're disrupting their tests on a daily basis. Got engineers pulling their hair out. They're trying to download the code, run it locally. They're trying to get the seed they use for the random values. It's still not working. It's just your little gem in there causing fucking havoc in someone else's repo. And maybe you name this like, I don't know, competitor's favorite tool.rb, and then hopefully they'll download it and use it. Again, please don't actually do this. This is just for fun. So that's our starting point, right? It's not too nasty. It's already a little bit grim. Like you probably don't want to get too deep into this. Let's try something a little bit different. What about instead of creating errors, we just take all your errors away, so you don't have any errors anymore. Don't worry about issues that are happening in production. It'll be all good. So there's this thing in Rails, or in Ruby, sorry, called method missing. And the idea is that if the thing you're going to call, like if you're calling a method called Steve or something, if Steve doesn't exist as a method, it doesn't just throw. It doesn't just throw immediately. What it does is first of it checks, hey, do you want to handle the fact that I'm calling Steve and it doesn't exist? And then if you're like, yeah, I absolutely do, it'll just call whatever you want it to, which is a little bit scary, but also a little bit fun. So let's have a go at doing something a little bit nasty around method missing. So if we call this error eater, what we can do is a similar kind of thing. We can make a module that's going to inject some code. And what we're going to do is we're going to inject it into active record. And this code is going to override method missing. It's going to take method, args, and keyword args. And all it's going to do is if the method hash is even, basically saying 50% of the time if you call in a random method, it's going to just return the object that you called it with. And then everything else, it's just going to call super. Perfect. I've somehow brought this back. Method missing is kind of half the picture. Even my Rails, like my Ruby cops complain to me. There's another function you kind of need to declare called respond to missing, which is this idea of like, should you even like concern yourself with this missing method? So we can define that as well. Respond to missing, which again is going to take the same args, keyword args. I've misspelled it here, but we will move on. And again, still misspelled. Wow. Again, we're going to do a similar kind of thing. We're going to call, like, if it's even, we're going to say, yeah, we're going to respond to this. We're going to totally handle this case of this thing happening. And if it's false, then we're just going to respond with the default stack like tactic. So we can declare again another injection function, which is not really going to do too much. Return again, inject the true. I love using Copilot, by the way, if you couldn't tell. I press tab a lot. It's probably one of my most used keys on my keyboard. It does everything I need. And again, we're going to go back to rail ties, add a new line in here. Come on, Copilot. Ooh, pretty good. It's pretty good. And then in features, we're going to turn on our error eater. And now when we jump back into a console, or if this code is running in production, we can have a bit of fun, see what's going on. So if we say user.first. Wow, that worked. And then wow, oh no, that's not a method, which is kind of what you expected wow to do. But if we reopen another console and we run wow again, wait, now it's not a method? What the hell's going on? So half your servers are going to be weirdly whacked out by this idea of not having this method defined, and other ones are going to like crazily happy about this method not being defined. So actual bugs now are getting weirdly swallowed by your production system or local system or whatever. We're causing a lot of weird pain for these developers. But you know what? They're probably thinking, we need to just scale down a little bit, chill out. We can't be running all this code. We don't know what's going on. Let's just cut back a little bit, cut traffic a little bit. And so when they do that, congratulations, there's a new opening. We can use their compute time. It's free real estate. You know, if they're not using it, like, come on, just give us a little bit of time there. We can do whatever we want. We can, I don't know, mine those Bitcoins for that other hacker that we can send them later. So let's have a go at actually just using their compute time. This one's a little bit more interesting in a way that basically when you require a gem, right, you can require whatever you want. And we rely on the fact that the gem isn't going to do anything nasty, in which case we've done a lot of nasty things. But now we're going to write basically effectively a Bitcoin miner in our gem. Please don't do this again. It's not good practice. But all we're going to do is just declare the start method and hopefully a stop method too. I'll put this here so I don't forget about it. And this is just going to say, just start 5 new processes. And in each process, we're just going to loop and pretend that we're actually mining Bitcoins, but I don't know enough about mining Bitcoins. I'm not gonna lie. So let's just say that mining Bitcoins is like taking 2 to the power of 1 million, and hope that that's close enough to what it actually is, which I feel like it mostly is. We can just return ourself here. That's fine. And then under stop, we want to find a way to stop this. So let's capture the process IDs out of this. And just do a little bit of caretaking here. So that we don't accidentally just start a bunch of random processes that we can't stop, hopefully. And then for each of these, it's just going to be pids.each, and we're just going to kill them. Ooh, thank you, Copilot. A little bit more co-piloting. We don't want turn, we want kill. We want them to die. And then process dot wait, PID, perfect. So now we have this little bit of code here, and it's required in our gem. So if it doesn't actually do anything unless we call start. So if we reopen our console, we can call Grindelwald miner start. If we keep an eye on my CPU usage up here, and I run this, whoops, we need to call new. This is our miner, miner.start. And then this is going to have an interesting time. So, you know, it's free compute, might as well make the most of it. This is me using all that extra compute power that Apple gave me. But we can't really rely on everyone who's consuming our gem to just run this command every time they open their server or open their console. We want it to just, like, you know, we know they actually want to do it. So let's just start it on their behalf. Like, it's for the best. It's for the best for them. So now that we have this start thing, we can just go back into our Railtie and do a similar thing, right? We can just make a new, what do I call this, miner? I think I call it miner, right? Yeah, sweet. We can make a new entry in here that's going to start a bunch of additional processes whenever we start something that the server does. So if we go back over to this tab, which is running the actual website, we can restart it. And lo and behold, our service is actually really heavy all of a sudden. I don't know what it is, but it's running a lot of Ruby shit over there. But we go to the website, it's still working. So who actually knows what's going on here? It's just a really heavy thing. Someone's going to do some optimization later down the line. It's totally fine. Right, guys. But yeah, it's kind of like an interesting thing where you could probably slip a lot of this stuff under the covers and not really know what's going to happen there, and hopefully get away with it. I know actually someone who got fired because they were legitimately doing this. They were leveraging additional compute power on a production server that was just free real estate and making a little bit of side cash on it, doing this kind of thing. It's actually creepily easy to get away with, which is the concerning part. All right, so we've disrupted the developer's day. We've taken a little bit of their CPU. Like, what's next? What are we going to actually get done? What about, well, we've got their compute time. Why don't we just take their accounts too? We could just have a play around in their app, see what they're doing, have a bit of fun. Just dig around a little bit. So let's just steal their passwords. By the way, this is my new favorite password that I'm going to start using. Password. I don't know what Dali was thinking when they made this, but password. It's got some weird phonetically close representation of the word password, but not so hot. But it's not going to be able to hack our accounts yet. We'll get there. Cool. So let's yank a couple of passwords. Similar kind of approach to what we've been pretty much doing the whole time, which is we're going to inject some code. This time, though, we kind of want a landing place for the data that we're collecting. Like, we can run it on their server, but ultimately we want to see it. So we can go to a nice little fancy website called, I think it's webhook.site. Hopefully. Yeah, all this is just like, you can send this site a webhook. It will show the data. Pretend this is your very secure vault of information that you're now pulling everyone's competitors' data into. So let's copy that and let's just put it in a constant webhook, just so that we have it for later. And again, we're going to do a little bit of an injection. So we're just going to create a new module that's going to inject itself into active controller, which is the thing that processes the requests in a Rails application. Not ChatGPT. What is this? Copilot. Don't get ahead of yourself. We're not there yet. We're calling process action. And this is the function that will run. I keep saying function. I feel like if you hate me because of it, because they're called methods in Ruby, fair enough, but it is a method. This is the method that runs whenever you make a request effectively. And what we're going to do in here is we're going to try and just grab all the params that were sent to the request. Whoops. So params.permit.toH. And then we're going to try and grab some sensitive data. All params. And we're just going to hope that they're sending email and password in the params. But we're also going to handle the fact that maybe they're sending it under a subkey called user. So user slice email password. All this is going to do basically is like, if you supply email and password as a post parameter or a query string parameter, it's going to make its way into this sensitive data hash. If you do it under the user key as well, it's also going to make its way into that sensitive data hash. So now we've got the data, like let's do something with it. But let's not disrupt them too much. So let's just start a new thread to allow them to allow us to send this code somewhere else. And if you don't want to use a nice little tool like HTTP party or another little like posting tool, you can do it natively inside of Ruby, but it's not super duper nice. We can just sensitive data. We can just send it like this. And let's just put this all in one line because we want to run this only if there is sensitive data. Right. So let's call present. Basically, all this is going to do now is try to look in the params, hope that there's email password. If there is, great. We send it off to our new webhook. We can have a look at it later. And because we don't want to disrupt them too much, they're having a bad day already. Let's just let their actual request go through and let them have a bit of just, relaxation time after what we put them through. So again, we're going to inject this similar kind of thing. Return if we don't know what an action controller is. Return if we've already injected it. Inject it. Injection true. Cool. That's pretty much it. The last thing we need to do, like before, set up our new line. Thank you, Copilot again. Bless. Saving the demo gods. And then mark it as true in here. And now we have our data. Oh, let's turn off this miner. That's going to cause me many pains if I leave it on. Probably let's just turn off the rest of this stuff. I'm sick of it. Cool. So we have our server. We can restart it. We can see there's nothing in our webhook still. Still waiting for the first request. But if we log out and if I can remember the login, I think I called it example.com, and our very secure password, which is password, not my actual password. Don't actually think it is. We logged in fine. And if we look back over at our webhook, oh, what's this? Raw content, Kingsley at administry.com, password. And you can see it over here too. Let me zoom in a little bit. Whoops, suddenly we've started leaking data out of our application. Uh-oh. And you can imagine someone entering their very secure password into your system as well. But like as an example, they could enter something random, and because we're capturing all the requests, we get that data as well, which is actually erroneous, but we could just try it and hope for the best, and maybe we'll get into that system. So again, like this is kind of hard to spot as well, right? Like if you're running a web app, chances are you probably have public internet access within your servers. If this is code running in the background, like auditing it is difficult. And that's why it's more important, I guess, to audit the actual source code rather than the individual network traffic that's happening. So we've got one more little example here, and I'm kind of running tight on time, but let's talk a little bit about just running whatever code you want. You know, we've talked about Ruby code. What about just some other code that can potentially run? So if you didn't actually notice, which I don't blame you for not noticing, this is like a special kind of README file. It's wait, hang on, this is not the README file. This is the README file that I want to see. This is a special README file. It's just really long. You can see my scroll bar here. It's really, really long, like really long. Like, oh my God, like, holy crap, this is a long, long file. In fact, if I look at it, it is, where are we? README. It's actually 524K long, which is a pretty long README. Like, I don't know how much information you're putting in your gem files, but that's usually not a good amount. Like, what the hell's going on here? And if we look at this, there's just a lot of white space text wrap happening. And if we just scroll across it with a cursor, there's some tab characters in here, but there's also, if we can find them, maybe not, there are space characters in here too. And if we have one type of one thing and one type of another thing, that's equivalent to a 0 and a 1. So what we can wildly do is decode our README file into a binary and run random code from it. So what we're going to do here is make a new method, self.run. All it's going to do is make a new temp file, which is basically just a file that cleans up when it closes the block. We're going to call it run, and we're going to mark it as a binary file. And we're going to grab a reference to it. Let's just call it temp file. And we're going to write out to it a pretty weird looking thing at first. Actually, I might just call this data. File.read, file.join. We're just going to get a reference to that README file. And the easiest way is just from the current directory to grab it from the base. And the reason I put this in a set of square parentheses is before I do that, actually, I'm going to grab the last line, which is our super duper long white space string, last. And I'm going to just basically replace every space with a, oh, you can't, sorry, let me just bring this a new line. I'm going to replace every space with a 1 and every tab character with a 0. And then I'm going to say, just make this binary code, please. That's what that does. It's a little bit confusing, but basically you can pack and unpack. It's like a Ruby like serialization tool. So now I have this data thing that looks like a whole bunch of binary data. Let's just put that in a file. Whoops. And straight after we do that, let's make the file executable. And immediately execute it. Is that what I've done here? Something like that, probably. Yep, let's just call it. So now we've got this file that we've just filled with random data from a README that we've turned into a binary data, and then now we're calling it. So we can try our best and hope that it does its job. Cool, we've got this runner. What are you complaining about? I have too many N's in here. Missing a def? Oh, I am too. Thank you. Perfect. Cool. So if we go back to our code over here, we can rerun our thing, and we can call Grindelwald runner run. And it runs hello from a hidden part of Grindelwald. And I didn't actually have to include this code in this thing, but I included it so I didn't forget about it. All it is just a bit of C code. And this is like the small script that I ran that basically does the undo of the pack, which is unpack. And it compiles the binary. Well, actually, I compiled it separately, but all it does is reads the binary file, converts all the ones and zeros into spaces and tabs, and just writes it to the end of my README file, which like you could just do and probably no one would find it. I don't know. I've never tried, except for this demo. I swear to God. And then all it does is just attach the README file, and then the runner, which actually doesn't contain anything potentially suspicious about like the execution. Like you could be looking at certain files in the file system, running any kind of other additional code. You could package some other random binary in the same kind of format and run it there. Hope for the best. It just kind of makes it very obscure. And again, we can just like, instead of requiring someone else to do it, we can do it ourselves whenever we want. So let's just, anytime someone runs a console or anything, whoops, I didn't want to run the debug tests. No, thank you. Let's get back over here. Anytime someone runs a console, ooh, did I call that right? Runner, run. Yeah, should be right. Maybe it isn't working, but regardless, we can basically outrun our code whenever we want, really. No, it's not showing up. Pretend it is. But basically that's kind of it. Like this has just been a little bit of a like exploratory mission into what it is some people could do. The important thing is don't do this yourself, but also be prepared about what you're pulling into your packages, right? Like you can be cautious, but also like do automated scanning. There's plenty of good tools out there that'll help you kind of get away from pulling things in. Maybe put a delay on new package updates as well. It's a pretty easy one. Wait a week until every release comes out. Typically in that time frame, things will get flagged before you can shim in your app, and review some of that stuff yourself. That's pretty much all I wanted to run through. I kind of ran out of steam by this point. I was like, you could probably do, I've left a little bit of space in this little malicious bar. So I don't know, there's probably more wild things that you can think about that I haven't thought about so far, where you could do some rogue things like create a makefile that moves a PNG over to an exe that runs a thing that creates a script that runs on reboot that copies you and pastes your Bitcoin addresses. So there's some wild things you can do. I've left space for, I guess, a reader exercise, but like keep it in house. That's it. Any questions?
What do you recommend to prevent, like the prevention mechanism for endpoints?
Yeah, it's a good question. There are a bunch of like automated scanning tools, like I mentioned before. Obviously, a good source to start with is GitHub posts internally, but also like there are a bunch of package repositories that show CVEs. So vulnerabilities that are being reported to the community. Make sure you're running things like bundle audit, which is basically a way to check if you have any security vulnerabilities in your existing gems that you've installed, including your dependent gems. Same kind of thing exists with like NPM as well. So you can call that. And then once you're kind of in production, there's a bunch of tools around host scanning and stuff like that as well. That's worthwhile looking into, especially if you're running like a large production workload. But when you're local, you can run all these individual tools, static code analysis, those dependency scanners as part of your CI, right? Just make them run, make everyone aware of the fact that you need to fix this ASAP, and just build it in as part of the code workflow.
Yeah, once security becomes security.
Yeah, that's
Your old issues, you know.
yeah. I mean, like even Dependabot, which is like totally free to use, especially for open source and for closed source stuff too, is it has like it'll prompt you to update the packages. But there are like way more advanced security tools you can use depending on kind of what your budget is and what your risk profile is as well. But again, like I really don't have a very good grasp on all this stuff. There's a lot more thought that a lot of other people have put into this. So it's worth doing a bit of research yourself if you're suitably concerned. It was in backticks, which converts to a string. Yeah, that's a good point. Yeah, it didn't std out. Find digest hash. Yeah, this is yeah, perfect. Create a minor. Yep, that's it. Thank you.